Now that we've set up the SUSE box to authenticate using LDAP, let's look at converting our Red Hat Enterprise box to do the same. It's currently using only etc password. We can confirm as such by connecting to one of the shell windows where it is and catting the contents of etc nsswitch.conf. This file tells you whether or not LDAP is at play with respect to any of the tables used by the operating system. And nowhere do we see LDAP in the document. We can even grep LDAP from nsswitch.conf. We should see some trace if LDAP is configured. It isn't, so that means the operating system is not using LDAP for any of the standard databases such as etc password, shadow group, protocols, services, networks, and so on. So with that said, we'll label this section set up RH5 to use LDAP. The version of Red Hat Enterprise 5 that we're using is listed in the Red Hat release file in etc. It's 5.3. This is the current latest. However, for all Series 5, major version 5, the procedure is the same. The tools are the same. The procedures are the same. So if you're running an earlier version or subsequently a later version of major version 5, you should be able to follow along with us precisely. So with that said, the features are the same as migrating the SUSE box. It's the ability to take advantage of the distributed LDAP directory. Distributed because it's currently being shared by multiple hosts. The SUSE Enterprise 10 primary system and the secondary and tertiary or slave servers. So the database is distributed, and we should take advantage of that. Now, taking advantage of it doesn't mean forfeiting etc password. It means working in conjunction with etc password, so we get to take advantage of having local and remote users. So let's add to our features list, and that is ability to support both local, which means etc password, flat file base, and distributed, which means LDAP users. And by the way, LDAP is the successor to NIS. It should be used in place of NIS. It is functionally more advantageous and more desirable because of the way it distributes and its performance, and as a result, and it's also an international standard. So use LDAP or consider converting to LDAP over NIS. So it's this ability to support local users and distributed users. And by local users, we mean standard users that are created during installation, such as root, or the system or daemon users, or one or more users that you may have created during installation to support your tasks on the box. But then obviously all of the other accounts can be downloaded remotely using LDAP. Now, the files, the config files, are identical. The components that need to be updated are identical. So note, components are identical to SUSE Linux, and those components include the pluggable authentication module, PAM, the name service switch, the LDAP client, which uses the etc openldap ldap.conf file. It's in a different directory but performs similarly. Now, Red Hat Linux includes a utility, system config authentication utility, to help us migrate the system towards LDAP. So note, use system config authentication to set up LDAP auth on Red Hat 5 Enterprise system. So our task is to set up LDAP, and we'll use that utility. Let's navigate to the shell. Now, we don't have an X-routed shell session to this remote system, so if we execute system config authentication. There are many system config utilities, by the way. If we tab them out, you'll see. But we're interested in the first one, system config authentication. If we execute this command, notice it dumps the text options, or dumps its capabilities, its options, to the shell, as opposed to popping up a graphical application. That's because we're not connected using x.org redirection. So connect using SSH with x.org redirection. That means to use SSH-X and connect to the remote system as root, and then X sessions will be redirected. By the way, we're connecting to Red Hat Linux using -X, but the -X in SSH behaves similarly on other distributions as well as other Unixes that support SSH and x.org. So this is by no means limited to connectivity to Red Hat-based systems. So let's terminate the session that's been open for the bulk of our studies, and then SSH back in using -X. And by the way, before we do, if you execute SSH help, you will see the multiple options that are supported, and a man, X is actually here but it's not described, a man SSH for the client eventually will return the functionality of X deep in the documentation. And you'll see later on that it redirects x.org sessions to the calling client, and there it is, enables X11 forwarding. If you find that when you use SSH-X that after having launched a GUI on the remote system it isn't displayed on your local system and you don't see any errors, chances could be that the remote SSH server does not support X11 forwarding. That's something you may want to adjust or take up with the administrator who is responsible for that remote system. So let's SSH in, and it doesn't know the host by the short name. Let's try it by the long name, and it still doesn't know it, which means we should update our hosts file. This is not a good thing. We'll update etc hosts. And supply the IP address. And the short name after the long name, the fully qualified domain name. Return to the shell and try it again. Now it connects, and we need to authenticate, and now we're in. Now there's no indication that X11 forwarding will take place. However, when we now launch system config auth, which should be in our history, but we don't see it, so let's go ahead and just type it out. System config, and use tab completion to complete it for us. And by the way, this has connected us to the wrong host. So that explains the problem. It's root at Linux CBT serve 4. That's more like it. And let's try it again. System config authentication. Now the graphical interface is displayed on our local system. Now this interface isn't as pretty as the YAS interface, but functionally it behaves similarly. It allows us to turn on various authentication methods and user accounts databases for a Red Hat system, such as NIS, LDAP, Hesiod, and Winbind, which connects your local Linux system to an Active Directory via Samba. So we're interested in LDAP. Now notice there are multiple tabs. User information, where to download user accounts databases. Authentication, the methods to use to authenticate, Smart Card, Kerberos, SMB, Winbind, LDAP, and options that may be important, such as the password hashing algorithm, whether or not to use shadow passwords, whether or not to create home directories the first time the user logs into the system. This is an important feature which will turn on because when the user from the LDAP directory logs in to a system for the first time, that user's home directory will not exist. So checking this box allows the PAM module to create the directory for the incoming user. So let's just note that. So B, launch system config authentication. C, enable create directory, home directory upon first login. D, enable LDAP in auth, and let's pop up that window again, user information screens. And by enabling LDAP in one screen will cause the values to transfer to the other screen. For example, in user information, if we select LDAP, configure LDAP, notice it has the settings. This is because the settings were pre-populated in the ldap.conf as a test. But these settings will persist when we navigate to the authentication tab, so we won't have to indicate it twice. Later on, when we set up encryption, TLS-based connectivity, we'll enable TLS to encrypt connections between the Red Hat system as a client and the server. Notice the IP address is that of the master server. This could be of the slave server, either one, Solaris or Red Hat Enterprise 5. But we point it to the master just for consistency, but it could be the secondary. So the LDAP search base DN is the root of the tree, the directory information tree. DC equals Linux CBT, comma, DC equals internal. That should come as no surprise that we index the LDAP client at the base DN. The server is referenced using the URI LDAP:///, similar to the way we reference hypertext documents using http:///, followed by the IP address. So the LDAP client library will connect to the LDAP server using an LDAP URI followed by the following IP address. If DNS is properly configured, we can indicate the name of the server, such as Linux CBT SUSE2, Linux CBT.internal, but be sure on the remote system that it is enabled by trying to communicate with the server. And we'll do that shortly after we have regained control of the shell. We'll click OK. For now, we'll bypass TLS connectivity. Now, if we navigate to authentication, LDAP is not checked, but when we check it and navigate to configure LDAP, notice the settings are downloaded. We'll click OK. And when we click the final OK, the Red Hat Enterprise system will change its key configuration files similarly to the way YAST changed the configuration files in the SUSE environment. Not much is returned to give us indication, but that is what indeed took place behind the scenes. So, ensure that etc hosts resolution is in order. And we should note system config auth, or authentication, updates the following files: etc/nsswitch.conf. This is the all-important name service switch file. It also updates etc/ldap.conf. This file stores LDAP client configuration information, whereas the nsswitch file is the name service switch configuration, telling it how to obtain, telling the operating system, that is, how to obtain resolution for various tables. etc pam.d system auth, and let's just point you to the auth file. lsltr system auth-ac is also updated so that PAM modules can take advantage, or calling PAM applications can take advantage of LDAP auth. We may grep LDAP from this file, and you'll see that just like on the SUSE side, for authentication, account management, as well as for password, and in this case, although it's optional, for session management, the PAM_LDAP module is called. So the configuration mirrors that of the SUSE box, or the SUSE operating system, but the file names tend to be in some cases slightly different. Let's look at the name service switch file. By the way, if you're curious as to whether or not LDAP appears in any other document, just grep LDAP from star and you'll see the files that are updated. Systemauth as well as Systemauth AC have been updated. All of the files in pam.d are included for authentication. Now let's navigate one directory back up and take a look at the nsswitch.conf file, where we see now the password entry. Instead of compatible like on the SUSE side, it explicitly lists two options, files and LDAP. So let's just copy this as an example. This is generally the type of update you'd make if you were doing it manually. So for example, password, files, LDAP basically says use first etc password, which also includes shadow. So let's include our brace notation. Then LDAP. That's the effect of that password entry in terms of what the operating system does with it. But this isn't the only line where LDAP is referenced. Scrolling through on, we see shadow. So for passwords, shadow references LDAP, group references LDAP, and other items are referenced, such as net group, auto mount if we set up mounting, and later on if we move other maps, such as for networks, protocols, and services, those two will have LDAP references. Now what does this all mean? Can we actually log in as a given user? Will it actually work if we try to connect to the system using the SSH protocol by SSHing in locally? Well, the only way to tell is to give it a try. So let's set up as another task. Test LDAP connectivity using SSH from slave LDAP hosts. Now obviously we'll just simply execute SSH, the name of the user. If you recall from our earlier section, we defined a user on the SUSE box named LinuxCBT LDAP1. So we'll SSH as LinuxCBT LDAP1 at localhost on the slave system. But before doing so, let's ensure that the Red Hat box, the secondary box, if we return to our graphic, that the secondary box is able to see the newly created user in YAST, the newly created LDAP user. We know that the organizational unit is people, so we can search the people OU. Let's history grep LDAP search. Let's look for one that searches an OU. Here is one. We can just use 888. So it searches the OU people. Now notice, it searches case insensitively. So in this case we indicated lowercase people. And there is the entry. The user commented LinuxCBT LDAP1 belongs to the people OU, which belongs to the suffix linuxcbt.internal. The distinguished name of the object is UID equals the user's ID, followed by the remainder of the hierarchy. Common name, which consists of first and last, or first and surname. Group ID number, given name, home directory, login shell. These are all entries that YAST populated into the DIT over on the SUSE box, and slurpd replicated over to the Red Hat box. So let's just note LDAP search returns the recently created LDAP user, LinuxCBT LDAP1. And again, this user was created on the SUSE side, but we now can take advantage of it. So with that said, let's try to SSH in as LinuxCBT LDAP1. It prompts us for authentication, and we indicated a simple password, ABC123. Now let's just take stock of what's taken place here. we did tell you that if a user is defined in LDAP, the user's home directory is not automatically created. So as we connect our Linux or Unix systems to LDAP, if PAM is at play and the functionality to auto-create home directories is configured, as is the case on the Red Hat side, then the directory will be created with some default entries. That's what we're seeing here. The default home Linux CBT LDAP1 was created. A directory for Mozilla and its plugins and extensions, so directories for those items were created. And now we're logged in as the Linux CBT LDAP1 user on the slave system. And we are in a newly created home directory. If we log out, then log back in, you'll see momentarily what happens with respect to directory creation. Nothing. The user's directory isn't recreated because it already exists. Now with respect to the user Linux CBT LDAP1 existing in the local accounts database, let's just confirm that the user doesn't. We'll grep Linux CBT LDAP1 from etc password. This is always a question that comes up whenever we teach anything relating to directories, and that is, how are we sure when administering LDAP that when we tell our tools to create users and or groups and various objects, that they're not created in the local accounts database? Well, if you've used a utility such as YAS or a utility such as LDAP add to create the user, then there's really no way that the user can end up in etc password database unless you inadvertently neglected using a utility like YAS to indicate that the user is an LDAP user. So in other words, it's unlikely unless you've made a critical mistake. So this user doesn't exist in the etc password database, and we should also confirm on the primary system if that's the case. So let's find a window to the primary system. We have none open here, so we'll just pick one and launch a new session. And then we'll grep Linux CBT LDAP1 from etc password. And the grep was unsuccessful, returning a non-zero exit status. So this user is truly derived from the LDAP database. Now what if we try to connect using the wrong credentials? Let's try an incorrect password, such as ABC1. Certainly it'll fail. That's the expected behavior, and PAM logs those failures to either var log messages or wherever the secure facility is rerouted or routed to. How about trying with a correct password but incorrect username? That's a correct password, incorrect username. So the user must indeed exist in the LDAP database. And if the database is down, then obviously the user will not be able to access the account, which is why it's important to maintain some backdoor accounts. We should just note that. It's important to maintain root and perhaps one additional account in the local databases or the local database of each server in the event of LDAP DB server corruption / unavailability. And this should be not much of a big deal to implement, because generally when you install an operating system, you're prompted for credentials for root, so at least root and various system accounts are always created. Then you are also optionally prompted to create a non-root level user with which to operate or use the system. So when installing SUSE or Red Hat, we're generally prompted to create a second user. So you should end up with at least two users, root and a non-root level user. You need those users because, again, if LDAP is down, you'll have no way of connecting unless you have backdoor users or you restore the LDAP functionality. Now another note, the Red Hat Enterprise System ships with a series of scripts from paddle.com, and they're located, so migration scripts are in user share open LDAP migration. These are scripts that you can download from paddle.com. They migrate existing users from the various files in etc., such as password group and other services protocols, etc., to the LDAP directory information tree. These scripts will create the organizational unit containers for you and populate them by migrating the users over, or objects over, to corresponding objects. Let's just take a brief look at that directory. We must have missed a character. And it's a series of Perl scripts. They all read a configuration file, migrate_common.ph. There are only a few variables that need to be updated here, and then you see migration scripts for distinct databases or flat files, such as protocols, services, networks, or the etc password file itself, which includes the shadow file, as well as files that will migrate everything, the migrate all files. So you can migrate all, such as what we see here, migrate all online or offline. So these scripts will help you if you have large etc password and other databases defined locally that you need to import into your new LDAP directory. There's a migrate base script which creates the organizational unit containers for you. And if you migrate all, then everything will be created for you, which includes top-level OUs, as well as the migration of etc entries to your LDAP server. So there is help. There are scripts out there. There are pre-written processes to help you move information or migrate that information into the LDAP server. But our recommendation is that you start off on a clean slate. It's usually much less messier if you can start off your LDAP environment in a pristine setting, although may not always be practical to do so or realistic to do so. That is the way that you should try to configure your environment. Now how about we set up as another task to create another user, linuxcbt LDAP2, task 3, create new LDAP user and authenticate to both hosts, linuxcbt SUSE2 and linuxcbt serve4. So we know the routine. We use YAS on the primary. If you're not using SUSE Linux, then use whatever tool you use to create users. It could even be the LDAP add utility, so long as you specify the right LDIF entries. And again, an LDAP search will dump those entries. So let's rerun LDAP search. You can create an LDAP entry using the following, for example. This is an LDIF entry that would suffice for creating a new user so long as we indicate a UID and GID, or at least a UID that's one higher, and if the GID is shared, then the same GID if necessary. But whenever possible, we should use tools to help us in terms of setting the passwords to the right crypt string and so on. So the first step is, on the primary system, use the YAS utility. Let's get an instance of YAS going here. We'll find our SUSE2 window. Let's make sure that our SSH was with -X. Otherwise, we'd have to create the user using the text version of YAS, which is fine as well. We'll launch YAS2. This will pop up momentarily. We'll maximize it. You create users in the security and users section using YAS. User management, and it's going to be a search filter modification, or a set filter, that is, modification to LDAP users, which forces us to bind to the DIT, the directory information tree, as the root DN. So the password is currently ABC123, a weak password that is traversing the wire, and there's the first user with UID 1002. Let's create a new user. linuxcbt LDAP2. Last name is user. LDAP2 with a simple password that YAS will complain about, of course. We'll click on accept, and of course it knows it's a weak password. We'll click on Finish, and momentarily this information should appear in our DIT. Let's close YAS, and from either system we can run LDAP search. Let's try it from the primary first. And there's Linux CBT LDAP2. And if slurpd is doing its job, let's grep I slurp, then we should be able to connect to the secondary and find the object. And there's the entry for Linux CBT LDAP2. So now it's in the directory. Very, very easy. Whereas in the days of, or when using flat files, we'd have to create the user on one host, then recreate the user on the next. But of course, this assumes that network connectivity between the corresponding hosts is solid. If you don't have network connectivity, then forget even using LDAP. This is all premised on having network connectivity. Now, let's SSH to the local system as, and it can be from a remote system. It doesn't have to be local. So let's launch a whole new shell altogether on our portal box, SUSE1. And then we'll SSH as Linux CBT LDAP2 over to Linux CBT Serve 4. We'll have to authenticate, and notice the directory structure again has been created. We're now logged in as a user Linux CBT LDAP2. We are in home Linux CBT LDAP2, not home Linux CBT LDAP1. So just like that, we can begin creating additional users and groups. We haven't even looked at groups, although groups are not as difficult to work with since they're simply used as a way of binding users for the sake of assigning permissions for the most part, or perhaps for mail routing. So we've got LDAP set up on both systems. So with that said, let's log out and move on with our configuration of OpenLDAP.